In this section, we're going to introduce you to exponential functions. And an exponential function is a function in the form of a times b to the x. So notice, and this is key to recognizing if it's an exponential function or not, is that x is in the exponent. Okay, then a is going to be your y-intercept, because that's the value of y when x is 0. If I plug in 0, I'm going to have b to the 0, which would be 1 as long as b is not equal to 0. I would have b to the 0, which is 1, and 1 times a is a. So a is going to always be your y-intercept, where it crosses the y-axis. B is what's called your growth factor. And that's what tells us if the graph is increasing or decreasing. Okay, so let's go through to see what these graphs look like. If your exponential function is increasing, then it's going to look like this. It's going to go up, left to right. And when it goes up left to right, your growth factor is going to be greater than 1. So for example, if I had the function 2 times 5 to the x, my a is 2 and my b is 5. Since my b is greater than 1, it's going to be increasing, so it's going to go up left to right. My value of a, 2, is going to be my y-intercept. So this would be the point 0, 2 where it crosses the y-axis. Now something else to keep in mind is unless you start shifting the graph around by subtracting or adding something to your function, then if you start moving it vertically, then that horizontal asymptote is going to change. So these features of the graph here is based on the mother function, the a times b to the x. When you start shifting, you have to keep track of those characteristics and make sure you shift those appropriately as well. So you're going to have y equals 0 is going to be a horizontal asymptote. A is going to be your y-intercept. B, when it's increasing, is going to be greater than 1. Notice because you have a horizontal asymptote at y equals 0, and this graph is going to get closer and closer and closer to the x-axis, but it's never actually going to touch it. Again, unless you shift it down, then it will. But when it's in this standard form, you're going to have no x-intercept. It's going to keep getting closer and closer to that horizontal asymptote, which is on the x-axis, but never actually touch it. Okay, your domain, if you look at your x values and you look at your arrows, it's going to go from minus infinity to positive infinity. There's no gaps or holes or jumps. It's a continuous function, so you're going to have all those values in between, from minus infinity to positive infinity. The range is going to be from 0 to infinity. Notice I didn't include 0 here. I didn't use a bracket there because remember, it doesn't touch the x-axis. It's going to be everything greater than 0. And this is always going to tie into your horizontal asymptote. So just like the range of a quadratic function is tied in with where the vertex is and whether it's a max or a min, your horizontal asymptote is related to what your range is, because your function is only going to drop down as far as that horizontal asymptote goes. Now, if it's decreasing, you pretty much have the same picture, only it's flipped over the y-axis, and it's going to go down left to right instead. So when you have a decreasing function, your b is going to be less than 1 but greater than 0. So it's going to be a fraction or a decimal between 0 and 1. So for example, maybe, I don't know, let's say 2 times 1/3 to the x. That would be an example. So my a is 2 and my b is 1/3. So again, since my a is 2, I would cross at the point 0, 2 on the y-axis. Unless I do some kind of shifting, vertical shifting, I'm going to have a horizontal asymptote at y equals 0. Okay, which means there's going to be no x-intercept. It never actually touches the x-axis unless we start shifting it down. It's not going to actually touch the x-axis, but it's going to keep getting closer and closer and closer to it. And in this case, when it's decreasing, b is less than 1, but greater than 0. The domain, again, is going to be from -infinity to infinity. For all exponential functions, you're going to have -infinity to infinity for your domain. The range is going to be from 0 to infinity, again, unless you start shifting your function, and this is going to be tied into your horizontal asymptote. It's going to be related to that because your exponential function is only going to drop down as low as your horizontal asymptote and no further. Okay, so now we're going to practice matching these graphs with the correct function. So if you notice, we have two functions that cross up here at a larger value for a y-intercept versus these 4. So we have 4 down here that cross at a smaller value and 2 up here that cross at a larger value. So these two are going to have a larger value of a, c, and d. So if you look, that's going to be this graph here and this graph here, because those two have the larger values of a where it crosses along the y-axis, and the other 4 cross lower. So now I know that these two that I just circled in dark purple are going to be either C or D. Now the difference, if you notice, if I look at D, if I trace D left to right, that's going up. So D is increasing. And if I trace C left to right, C is decreasing. So this is going to help us figure out which one is C and which one is D. Because I know my growth factor should be bigger than 1 if it's increasing. So that means this has to be D, and C would have to be this one down here, with a growth factor that is less than 1. So now we have to figure out the other 4. So if you look at E and F are both increasing. However, E is increasing at a much faster rate. So my growth factor for E is going to be a bigger value than F. So growth factor for E is, whoops. There we go. The growth factor for E is bigger than the growth factor for F. So then I'm going to look for 2 growth factors that are bigger than 1 because they're both increasing, E and F, but the one that's bigger is going to be E. So if you look, This one here, since it's bigger than 1, is going to be increasing. This one here is decreasing, so it's not this one because 0.92 is less than 1, so this is going to be decreasing. This is going to be increasing because it's greater than 1, the b is greater than 1. And this is going to be decreasing because my b, my growth factor, is less than 1. So E and F is between this one here and this one here. And we said since E jumps up faster and is growing bigger than F, then that's going to have the bigger growth factor. So between 1.61 and 1.25, this has got to be E, and this has got to be F. Okay, and that leaves us with, if I scroll back up, the graphs of A and B. The graphs of A and B are decreasing because they're going down left to right. B is decreasing at a much faster rate. And since that's a decreasing function, this is going to be A, and this is going to be B. So when you have a decreasing function and it's decreasing faster, you're going to have a smaller number for your B. So for this example, we are going to find the end behavior for the graph of -4 times 5 to the x plus 1. And they're using a little bit of different notation than what we have so far, but this is just saying as x goes to -infinity, where does y go? What is y approaching? And they're just using a term that you will definitely see if you have to take calculus, which is called the limit. But it's the same idea. We're looking to see as x goes to -infinity, what happens to y? And they're using f of x instead of y. So let's look at the graph so that we can determine this. Okay, so first we're going to look at the mother function, 4 to the 5x. The negative in front tells me they're the reflection, and then the plus 1 tells me that there is a vertical shift up. We got to think back to our graph shifting rules. So the mother function would be considered 4, 5 to the x. So let's graph that first. So there's going to be a horizontal asymptote at y is equal to 0, so it's going to flatten out here. Let me draw that in yellow. Here's my horizontal asymptote. It's going to be an increasing function because my b is greater than 1. That's my b is 5. It's greater than 1, so it's going to be increasing going left to right. And my y-intercept is 4, so it's going to cross here on the y-axis at 4. Now, when I deal with that negative that's in front of the 4 to the 5x, when we put a negative in front of the function, that means that's going to be a reflection over the x-axis. So now to graph -4, 5 to the x, it's going to flip over the x-axis, and it's going to look like this now. So this is going to cross now at -4, but it's still going to flatten out here at the x-axis. Okay, now the last step is to bump everything up 1. So if my horizontal asymptote right now is at y is equal to 0, when we bump it up, it's now going to be at y equals 1. And so when I graph my final graph and I bump it up 1, my y-intercept is now going to be -3, and it's going to look like this. And now it's going to flatten out here at 1 instead. And it's going to come up like this. Sorry, I don't have a very steady hand. Okay, so now we can answer the question, because this final graph here is the graph of -4 times 5 to the x. This graph in blue right here, whoops, plus 1. This graph right here in blue was the -4 times 5 to the x, and then the green was when we bumped it up 1. So our final graph is in green. So now we have to ask a question, as x goes to negative infinity, y goes to what value? What are we getting closer and closer to for the y value? So if I start tracing my final function that we're looking at, the negative 4 times 5 to the x plus 1, if I trace that going in the direction of x is negative infinity, I'm getting closer and closer to that horizontal asymptote of y is equal to 1. So we're getting closer and closer to the y value of 1. So that is going to be my final answer.